Now, there's another place where your author uses an interesting notation, and I don't know, I don't claim that he's wrong, but it's a little bit questionable. So what we have, this is a sequence, right? It's just a set, right? And all this guy spits out is A1, A2. Typically, in mathematical parlance, you can stop at A3, and then you just go dot, 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 and you go A sub n, and that means, okay, it's a set from A1 all the way up to n, or from A1 all the way up to AN, A sub n. And this, of course, assumes that we have more than 3 elements in the set. Now, there's something called summation note. Whoa, that got a little crazy. There's something called summation notation, and I want to make sure that I use the same notation that your author uses. Although you will see this change from mathematician to mathematician. All right, so let me show you how this works. If I say that this is the sum, hopefully you've seen this. This is just a giant sigma. And it's written like this. You got a little subscript here. It says from k equals 1, and you got the sum sign, and let's go to n. Now, what this really means is the sum from k equals 1 to k equals n. And then if we throw in an a sub n, or excuse me, an a sub k, now that's where that's where it's going to change in your calculus text. If I throw in an a sub k, now watch what this really means. So the way that this would be said is the sum from k equals 1 to k equals n of a sub k. Now you may say, well, Ridley, wait, we just changed from k's to n and n's to k's. Don't panic. The rules are still the same. We're assuming that this thing spits this out. I can call it an n, I can call it a k, I can call it whatever I want. Okay, what you need to understand is that this turns into an A1 plus A2 plus A3 plus dot 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 plus A sub n. Now, the problem is that your author sort of offhandedly refers to this as a sequence. It's not. This whole thing is a series. When you add up elements, you create what's called a series. When you list elements, you create what's called a sequence. And like, I don't know if any of you have ever taken like the Mensa tests or, played with those. The two get interchanged all of the time. But from a strict mathematical context, series means add them up. Sequence means stick them in a box. Order them. You got to order them in the box, starting at A1 and finishing at AN. A series means you got to add them up. Okay, I know that sounds a little anal for me to be like, well, he screwed it up. I don't think he screwed it up. I don't know why he did what he did, but that's the reference. Okay, so let's just go laws. Let's talk about the properties. They're real simple. This doesn't take long at all. This whole section doesn't take long at all. We're going to talk about properties of series, even though your author refers to them as properties of sequences. So properties. I hate it when I have to write. I wish I could just think it and it would pop up. Series is, and I guess I have to do that, don't I? All right, so all we're going to do is we're going to suppose A sub n, B sub n, and C, or what? Well, try that again. Sorry, guys. A sub n, B sub n are sequences. And C is a constant. Now remember, don't be afraid, because those A sub n and B sub n's can change to k's, which they're gonna in the notation. All right, so don't worry about it. So let's look at property number 1. If I take the sum as n, or excuse me, as k, goes from 1 to n of C times A sub k. All right, so look at what happens. This turns into C times A sub 1 plus C times A sub 2 plus C times A sub 3 plus dot 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 C times A, plus C times A sub n. So that's why this guy right here is why they wanted to make sure that very last term is the general term. So that's why they use A sub n here, but A sub k here. I know it's confusing. I apologize. Well, look at what happens. All of these terms have a C. So I can just as easily factor out the C, do A sub 1, plus A sub 2, plus A sub 3, plus dot dot dot, plus a sub n. And if you think about it, remember this big sum sign, this sigma, just means add them up, and here's a bunch of stuff being added up. So what I can do is I can factor that constant term out and leave this as the sum as k goes from 1 to n of a sub k. I should use this as a script k. I need to be consistent. Yell at me if you see me being inconsistent with my notation, because a non-script k and a script k in mathematics implies something different. Now, what does this really say? It says you can factor out a constant. That's all it says. All right? That's all it says. So number 2, how about this guy? If I take the sum as k goes from 1 to n of a sub k, and I'm going to do plus, but when we're done, we'll throw a minus in there, okay? I'm going to do a sub k plus b sub k. Well, look at what happens. Again, I'm not going to bore you with too much of this, but well, some of you are like, "You're too late, Ripley." Shut up. All right? Plus a sub 2 plus b sub 2. See how I'm just grabbing them term-wise. Plus a sub 3 plus b sub 3 plus dot 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 plus a sub n plus b sub n, right? Well, the commutative property of addition says that I can flip-flop these things around, and then I can use the associative property to turn this guy into a sub 1 plus a sub 2 plus a sub 3 plus dot 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 plus a sub n plus b sub 1 plus b sub 2 plus b sub 3 plus dot 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 plus b sub n, which the sum of a1 through an is just the sum as k goes from 1 to n of a sub k plus the sum as k goes from 1 to n of b sub k. Now, think about it. If I change this plus into a minus, then all of these guys, it's not very hard to figure out where this goes. If this gets turned into a minus, then all of these guys get turned into minuses right there, and there, and there, which means that this guy right here, because I can factor that negative out, gets turned into a minus, and I can use exactly the same property. Now, the funny thing about this is the way in which you say this. Think about what this says. This says the sum, because that's what sigma notation means, the sum of a sum is the sum of the sums. All right, enough said. All right, I know I'm not funny. I just think I am. Let's do this guy. How about this? Will drive you a little crazy. Now here we go. This is going to be the sum as k goes from j plus 1 to n of a sub k. Now, what we really need to make sure that we understand here is that j, I'm going to put this way out here, is that j lives between 0 and n. It's one of our positive reals, but it's less than n, and it's greater than 0. Now, this gets a little frightening, but don't worry about this. Let's write out the first few terms. I always yell at my calculus kids when they're freaking out about a series. I'm like, dude, just write the first few terms. Watch what happens. So I'm going to have a sub j plus 1, right, plus a sub j plus 2, that's supposed to be a j, plus a sub j plus 3, and then somewhere out here, plus dot, 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 in my own way, I get a sub n. Remember, these are just integers. Now, let's look at the sum as k goes from 1 to n of a sub k. Now, remember, j lives somewhere between 0 and n. So I'm going to do something. Watch this. That gives me a sub 1 plus a sub 2 plus a sub 3 plus, now I'm being a little bit presumptuous here about where j is. I'm assuming that it's not a sub 1, a sub 2, or a sub 3. All right? And you'll see why here in just a sec. Plus dot, dot, dot. Now, plus a sub j minus 1 plus a sub j plus a sub j plus 1 plus dot, 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 then plus a sub n. All right? Now, again, don't freak out about this j. It's just a number between 0 and n. Now, look at this. What are we looking at here? We're looking at this part of this sum. So if you think about it, if I were to subtract out, let me change my color again. If I were to subtract out this part from 1 to j, from the series from 1 to n, wouldn't I be left with a sub j plus 1? I don't know if you guys heard that, but a frog just crawled out of my throat. So what that says is that this is exactly the same as the sum as k goes from 1 to n of a sub k, and then simply subtract out the sum as k goes from 1 to j of a sub k. You see what I mean? If these guys go away,